Hi everyone, this is your math guru. In this video, we're going to be solving some questions that deals with the nature of roots of a quadratic equation. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example, it says, calculate the value of d for which the equation 5x squared plus 6x minus d equals to 0 has equal roots. For equal root, your discriminant or your delta must be equal to 0. Like quadratic equation 5x squared plus 6x minus d equals to 0. To find that delta, a is 5, relating it with the quadratic equation ax squared plus bx plus c equals to 0. Our b equals to positive 6 and our c equals minus d. Delta, which is our discriminant, equals to b squared minus 4ac. It's the value under your root from our quadratic equation x equals minus b plus minus square root of b squared minus 4ac all over 2a. The value under the root, which is a b squared minus 4ac, is our discriminant. So going back to our question, b squared, that will be 6 squared minus 4 times a, that's 5, times c minus d. That will give us 36. 4 times 5, 20, times minus d, that's minus d, times minus, okay, let me write it out, that's minus 20d. And if we open up the bracket, we're going to have 36 plus 20d. And for us to have equal roots, the value of our discriminant must be 0. So we are going to equate this to 0. If we move our 36 to the other side, we're going to have 20d equals minus 36. Dividing both sides by 20, we're going to have d, this cancels, d equals, simplifying a fraction, minus 9 over 5. That's dividing both the numerator and the denominator by 4. So the value of d for the equation 5x squared plus 6x minus d equals to 0 to have equal roots will be minus 9 over 5. In the second example, we have shown that the roots of the equation kx squared plus in bracket 2k minus 1 multiplied by x equals minus k plus 1 are natural for all values or rational values of k. A discriminant, which determines the nature of a root, can be found by finding the value of b squared minus 4ac. Our equation as given is kx squared plus in bracket 2k minus 1 x equals minus k plus 1. We need to rewrite our equation to look like the standard equation of an quadratic equation, which is ax squared plus bx plus c equals to 0. So we are going to move all the terms to one side, and doing that, we'll have kx squared plus 2k minus 1 x minus on the right hand side becomes positive, and plus on the right will become negative when they move them, or when they are moved to the left hand side of the equation using the balance method. Therefore, our a is the coefficient of x squared, our b is the coefficient of x, and this is a constant. Writing that out, we have a equals to k, b equals to k minus 1, and c equals k minus 1. If we put that back into our formula for discriminant, we're going to have discriminant equals b squared, because it's an expression, I'm going to put that in a bracket, minus 4 times A, which is K, times C, that's K minus 1. It's a nested bracket. This will give us, if I expand or FOIL, I'm going to have 4K squared minus 4K plus 1 minus 4 in bracket K squared minus K. If I resolve or simplify, I'm going to have 4K squared minus 4K plus 1 minus 4K squared plus 4K. Collecting like terms and simplifying, 4K squared minus 4K, that cancels out, minus 4K plus 4K, that goes off. I'm left with delta equals to 1. And we know that 1 is a perfect square. So therefore, the coefficients are rational. Therefore, the roots are rational for all values of K. Also note that the root is also real. Let's look at one more example. The roots of a quadratic equation are given by x equals minus 4 plus or minus square root of k plus 1 multiplied by 3 minus k all over 2. If k is 2, determine the nature of root. And b, determine the values of k for which roots are non-real. From a quadratic equation, to answer the a part of the question, we know that x equals minus b plus or minus square root of b squared minus 4ac, which is our discriminant. That will determine the nature of our root all over 2, where our delta is b squared minus 4ac. Relating that to the equation given, we have x equals minus 4 plus or minus square root of, in bracket, we have k plus 1, 3 minus k, all over 2a. So the value under our root is our discriminant. So the question says when k is 2, our discriminant is going to be k plus 1, 3 minus k, which is the same as, we're going to replace all occurrence of or instances of k with 2. So that's 2 plus 1, 3 minus 2. Therefore, our discriminant is going to be 2 plus 1, 3 times 1, which is 3. If discriminant is equal to 3, therefore, that means our discriminant is greater than 0. That is positive. Any value greater than 0 is positive. But it's not a perfect square. Not a perfect square. Therefore, the root, nature of root, equals unequal, irrational, and real. For the second part of the question, it says, determine the values of k for which roots are non-real. For the root to be non-real, your discriminant must be less than 0 or having a negative number. Therefore, the value under the root, which is our discriminant, we have k plus 1, 3 minus k, must be less than 0. That means k plus 1 less than 0, k must be less than minus 1, or 3 minus k less than 0. Then we have 3 is less than k. I'm putting that on a number line. We have minus 1, we have 3. We're going to have a graph in that direction. Thanks for watching. Bye.